Hey guys, so today we're going to be venturing into chapter 10, but we're only going to do 2 lessons. And so the first one is lesson 10.1, and we're going to learn how to find the volume of a rectangular prism, which is, let me try this again, rectangular prism, there we go. And that is a fancy name for a box. Okay, so all boxes are rectangular prisms. All right, so yes, we have definitions. So let's start. Let's figure out what volume's all about. Remember, we've been spending all our time talking about area. So volume is the amount of space inside a three-dimensional figure. So we were talking about flat things in area. When we talk about three-dimensional, these are things that if you put them on a wall, they would stick out. Now, I am going to tell you that the space is going to be filled with perfect cubes. Perfect 1 by 1 by 1 cubes. Okay, whereas with area, it was perfect rectangles. So little squares, perfect squares, okay? All right, so because of this, the measurement is cubic units. So measured in cubic, or little cubes, units. So how many little cubes fit in that shape? So just to let you know that we have 2 options. Well, we have a couple of options. We can label it in cubic inches, and we could spell it out. We could abbreviate cubic to CU, and then inches would be CIN. But the way I prefer to do it would be with the exponent 3. Okay, that's the best one because it takes the least amount of work, right? So you might be saying, okay, that's all fine and dandy, but what do you mean by that three-dimensional figure? Well, I did kind of tell. So we're going to write down that definition. And remember, make flashcards if you don't know the words. Three-dimensional figure. Well, let's just do figure, not a figures. Let's do figure. Singular. And that's going to be, has a length, a width, so like a rectangle, but then it has a height. Okay, and we'll talk about that in just a second. What role do each of these play? So let's talk about the word prism. What is a prism? So we have different three-dimensional shapes, and we're only going to focus in on prisms, but you'll also learn about pyramids as well, which you studied when you were studying ancient Egypt, right? So a prism is a three-dimensional figure with 2 parallel bases that are congruent. So parallel means they're never going to come in contact with each other, and congruent means same shape, same size. Okay? And then these are referring to shapes. So congruent, same shape, same size, shapes. Okay? So let's talk about what makes a prism a rectangular prism. So what we're going to learn is that the bases are going to dictate the name of our prism. So a rectangular prism is a prism with congruent rectangle bases. Now what's interesting is that in prisms, the bases can be different shapes, but the sides are all rectangles, okay? And that comes more into play when we talk about surface area, but we aren't this year. Okay, so let me draw a picture, and this is probably my favorite shape to make, and so I'm going to show you how I do it. To make a rectangle become a rectangular prism, I draw my rectangle. I draw two sides kind of slanting away from it, and then the top also slants, and then comes down, and now I use my Superman vision, and I can see right through the shape. So the dashed is if I could see through the solid surface into what's behind it. Okay, so I'm going to highlight, well, I'm going to color. Let's do it this color. So these kind of peachy pink are what I call the bases. So that's the top and the bottom. So those are the bases. Okay. All right. Now, what else? And these are the ones that are congruent, right? Now, here's the interesting thing. When you look at a rectangular prism, all the opposite sides are congruent. So you've got the top and the bottom. Those are what we're going to call bases. You have the front and the back, and you have the sides. So the front and the back are congruent, and the two sides are congruent. Ooh, sorry, that's my elbow cracking. Now, guess what? Oh, we have a formula that we need to memorize. Yes. Formula. And I'm going to write over here, memorize. Now, I am going to tell you, we're going to talk about a general volume formula, and then we'll break it into the specific one for the rectangular prism. But if you remember the general formula for volume of three-dimensional shapes, and you know the formulas for the areas of the base shape, then you don't have to memorize separate formulas, okay? So this is what I'm going to call the generic volume formula. And it's going to just be a bunch of letters. V equals big B, big H. Now I'm going to tell you your book does not distinguish between big and little letters, but I do because of the role they play, okay? So, what do these mean? This is volume, is V, and equals, and then we're going to have the area of the base. That's your big B, okay? It's telling you, okay, if you have a rectangle base, what's the area of that rectangle? Okay? Then you're going to multiply it by the height of the prism. Now, this is what's cool about the prism. It separates the bases. So it's a line that draws from one base to the other base. Okay? So that's pretty cool. Now, so let's go back to this generic formula. And let's remember how we figure out the area of a rectangular, well, of a rectangle. So here's your rectangular volume. Is that we get length times width, but everything else stays the same. V stays the same, equal stays the same, and times the height of the prism. Okay? So that's going to be the volume formula that we're going to use. Now, on the next screen, we're going to practice problems, and the problems we're going to practice are, hey, find the volume of the shape, and then the other one is going to be find the missing dimension. Okay, so let's work on that. And next we go. So let me get those directions in. Find the volume. Of the following rectangular prisms. Okay. So I'm going to tell you certain of these drawings I'm better at than others. It's like I'm really good in one direction, but not so good in the other direction. So that's just the way it goes. Now let's get our Superman going here. And then we got to, again, like I've said in the past, you got to trust the dimensions, okay? Trust what the numbers say, not what it looks like. So I'm going to put what letters each of these are. So the base is on the bottom. So we've got two sides, and if you notice here, it says it's 5. Well, guess what? In a rectangle, opposite sides are the same. Here's another rectangle with the same thing. So this would also be 5, right? So this would be considered the length of the rectangle. Now the width is pretty easy because he's just sitting right there. Now notice that my bases are my top and my bottom. So the line that separates the top from the bottom would be the height. Okay, so that's what I'm going to use for my formula. So I start with the basics. V equals length times width times height. And that equals, we've got 5 times 5 times 5. Now, what you should notice is all these dimensions are the same. So what this tells me is that you have a cube. So a cube is a rectangular prism where all the dimensions, all the measurements are the same. So then we just start doing math, and I get 5 times 5 is 25, and then times 5, and then that's going to give me 125. So then I'm going to add my label, and this one's going to be cubic inches. So even though I say the cubic part first, the exponent comes last. Okay? All right, let's try another one. Let's see if I can do a good job. Ooh, sorry if you heard that. And then let's get the Superman going on here. Okay, there's my Superman going on. And I'm going to label, we have 7 inches. We've got 11.5 inches. And we've got 4 inches. So again, I'm going to use the bottom or the top to be my base, and then the height's going to be the part, the side that separates the two bases from each other. So I'm going to go with the, in the front here would be the length. On the left, that would be the width. Oops. And then the 4 is what's going to be the height of the prism, separating the top from the bottom. So we take our formula, and this is definitely not a cube, and then we start plugging numbers in. So we get 11.5, so I'm just getting you used to the fact that you may have decimals or fractions to deal with as well in this unit. That's why we're practicing them this week in Alex. And then we have height is 4. Alright, so we just multiply any way you want. I'm going to do 11.5 times 7, so I'm going to ignore the decimal for a moment. So I get 35, I get 7 and 3 is 10, I get 7 and 1 is 8, and there's one digit after the decimal point. So that gives me 80.5 times 4, and then I multiply that answer by 4. So I get 20, 0 and 2 is 2, and then I get 32. But there was one digit after the decimal point. So I get 322. I don't need to leave the decimal point when it has a 0 coming after it. And then cubic inches. Oh, I have inches twice. And then number 3. Let's see if I can do this one. We're going to do this slightly slanted. Ooh, that's more than slightly. Oh well. Okay, and then we're going to go boom, boom, boom. Put in my Superman. Oops, my Superman vision had a bump to it. Okay, and then let's put in some numbers, and it says on the top here, we have 8 meters from there to there. On the right side, we have 12.5 inches. See, even I got used to inches, meters, and that goes from here to here. And then this piece is going to be 3¼ meters. Okay, so let's label out what we got. Let's see, so the length of my shape, my base, is going to be this guy, which leads to this guy. So they're all the same. See what I'm talking about? All of those would be 8. So he is going to be the length. The width is going to be marking here. See, that's the width. So that's at 3¾ And then the height is what's separating the two bases from each other. Okay, now we get into the calculations. And we get volume equals length times width times height, which is going to be 8 times, let's see, 3¼ width times the height of the prism, which is 12.5. And then we're going to just start doing math. So we're going to convert from mixed numbers to improper. We can't do math before doing that, so we'll make 8 a whole improper fraction. 4 times 3 is 12, plus 1 is 13, so 13/4. 12 times 2 is 24, plus 1 is 25/2. And then try simplifying. 4 goes into 8 twice. 2 goes into 2 evenly. That leaves me with 25 times 13. So I multiply off to the side, 6, 7, placeholder, 5, 2, and then we end up getting 5, 12, 3. We get 325. Boy, can you hear the helicopter? I swear, my neighborhood is so noisy today. And then we're going to have cubic meters. It's been crazy. I keep moving around trying to find the quiet spot, and it's just not happening. Okay. So now we're going to be looking for the missing dimensions. So find the missing dimension. Of each prism. So here, I'm going to give it to you 2 ways. First way would be giving you a diagram. Second way is going to be just listing out the numbers. Oops. That one wasn't quite the angle I was looking for. There we go. That's better. Get my Superman vision going on. Okay, and then it's going to tell me over here is 4 meters, over here is 6 meters, and here is H. Now your book is going to use lowercase, but I'm going to use uppercase, okay? And they're going to tell me V equals BH. And that's the base, area of the base times the height of the prism. So let's go ahead and kind of do our color coding. So the 6 is the length of the rectangle. 4 is the width of the rectangle. And obviously H is going to be the height. Ding, ding. Right? Okay. So let's plug in what we got. We're going to take the... Oops, sorry. I forgot. Nope, that's all good. I forgot. Over here I got a problem. This is what is a problem. That's 84 cubic meters. There we go. Hello. Now let's start with the formula. Yikes. So actually I'm going to do it to the side here. So V equals the area of the base times the height. Since my base is a rectangle, I'm going to multiply the length and the width. So that's going to be 6 times the 4. And then I'm going to multiply that by the height of the prism. That's separating the top from the bottom. And that's going to be, we're just going to leave it as H. Oops, I forgot something, didn't I? I know what V is. Let's put that number in, shall we? So the volume, I'll just do orange, will be 84. Okay, so let's start doing some math. We get 84 equals 24H. So the inverse of multiplying by 24 is dividing by 24. So I'm going to use my symmetric property and change the result. So I get H equals 84 over 24. Now I notice that these two both have a 4 in common. Oops, sorry, why did I put -4? Boom. And 4 goes into 84 21 times and into 24 6 times. And then I go, oh, look at that. They both have a 3 in common. Some of you might have said, I saw that they both had a 12. And you'd be right. You get 7 halves, which we're going to change to a mixed number since this is a measurement. And we get, it's not 2, but 3. 2 goes into 3, or 7 3 times, which is 6, with 1 left over. So we would say the height is, or the height of the prism, three and a half, and it would just be regular meters. Okay? All right, let's do one more, and this one's going to just tell us, a very blank, here's what you get. So the volume is going to be the 94.5, and this is going to be cubic kilometers. And then they're going to tell us the length is 7 kilometers. They're going to tell us the height of the prism is 3 kilometers. And the width is the mystery number. So we're going to solve for the width. So we're going to have V equals length times width times height. We're going to replace the width with 94.5, the volume with 94.5. The length is going to be 7, width is going to stay W, and the height is going to be 3. So I multiply and I get 94.5 equals 21W, then I divide both sides by 21. So I'm going to continue my math over here, and I'm going to divide 21 into 94.5, bring that decimal point up. Let's see, 21 goes into 94 4 times, which is 84, with a difference of 10. That's smaller than 21, so I keep going. Bring down the 5. 21 goes into 105 5 times, and it works out evenly. So we get W equals 4.5. So we say the width of the prism is 4.5 kilometers. And there you have it. All right, good luck, guys. We'll talk about this in class and practice. Bye now.